In 2012, archaeologists opened a tomb in eastern Sicily dating to 1000 BCE, the Iron Age, long before Greek colonization. Inside were remains of an indigenous Sicilian family. When geneticists analyzed their DNA, they found something that made no sense. These people who lived before Greece ever touched Sicily already carried 25% Caucasus and West Asian ancestry, components that shouldn't be there, components that suggested Sicily had been connected to the Near East for thousands of years before recorded history. The discovery revealed a 3,000-year secret. Sicily's genetic character wasn't shaped by Greece or Rome. It was locked in during the Bronze Age by maritime peoples whose names we've forgotten but whose DNA still dominates the island today. Modern political maps show Sicily as part of Italy. School textbooks teach that Sicilians are southern Italians, but when geneticists analyze Sicilian DNA, they see something radically different. Sicilians cluster closer to people from the Greek islands, Cyprus and Crete, than they do to people from Rome or Milan. There is a biological boundary running through Italy called the Rome-Ancona line. North of this line, populations show strong genetic ties to Central Europe. South of it, you enter what scientists call the Mediterranean genetic continuum, an ancient biological bridge stretching from Sicily through the Greek islands to Anatolia and the Levant. Northern Italians received massive amounts of steppe ancestry from Bronze Age migrations that brought Indo-European languages to Europe. Sicilians didn't. While northern Italy was being transformed by migrations from the Pontic-Caspian steppe, Sicily was receiving waves of people from the opposite direction, from the east, from Anatolia, the Caucasus, and the Near East. The story begins 15,000 years ago when the first humans reached Sicily after the last ice age. These Paleolithic hunter-gatherers carried a mitochondrial lineage called U5b, common across Western Eurasia. They lived in isolation for thousands of years, their small population drifting genetically in caves and coastal settlements. Then, 8,000 years ago, everything changed. Farmers arrived from Anatolia and the Near East carrying completely different DNA. Mitochondrial lineages U8b, K, J, and T appeared suddenly in Sicilian remains. Ancient DNA from sites like Grotta dell'Uzzo shows these Neolithic farmers shared 93% of their ancestry with farmers from the Balkans and Greece. The local hunter-gatherers contributed only 7%. This wasn't gradual mixing, it was near total population replacement. The Anatolian farmers became the genetic foundation of Sicily, establishing an East Mediterranean baseline that still dominates Sicilian DNA today. But the Neolithic replacement was just the beginning. The real secret lies in what happened next, during the Bronze Age between 2000 and 1000 BCE. During this period, Sicily experienced a massive influx of ancestry from the Caucasus and the Iranian Plateau, what geneticists call Caucasus hunter-gatherer or West Asian components. This ancestry arrived without the corresponding steppe influence that was reshaping the rest of Europe. By the Iron Age around 1000 BCE, Sicilians already carried approximately 20% of a Cypriot-like or West Asian genetic signature, combining Anatolian and Levantine elements. Here's what makes this extraordinary. This East Mediterranean character was already established before the Greeks officially colonized Sicily in the 8th century BCE. The island's genetic profile was set before any of the famous historical migrations that textbooks emphasize. Scientists theorize this Bronze Age influx came from maritime groups crossing the eastern Mediterranean. Ancient texts mention the Sea Peoples, mysterious raiders who destabilized civilizations around 1200 BCE. Among them were the Shekelesh, linguistically linked to the Siculi, one of Sicily's indigenous tribes. Were the Siculi actually Near Eastern seafarers who settled Sicily centuries before recorded history? The genetic evidence suggests yes. By the time written history begins, 3 distinct groups inhabited Sicily: the Sicani in the central and western regions, the Siculi in the east, and the Elymians in the northwest corner. Ancient writers argued about their origins. Thucydides claimed that Sicani came from Iberia, but modern DNA analysis disproves this. The Sicani show genetic continuity with earlier Bronze Age populations. They were indigenous, descendants of those early Anatolian farmers, modified by Bronze Age admixture. Their language was non-Indo-European, a substrate that left traces in Sicilian place names with endings like "ina" and "ara." The Siculi were different. They arrived around 1200 to 1000 BCE from mainland Italy. They were an Italic people, speakers of an Indo-European language related to Latin. They brought the first significant mainland Italian genetic influence to Sicily, pushing the Sicani westward. The Elymians remained the most mysterious. They occupied the extreme northwest around modern Arice and Segesta. Ancient sources gave them a Trojan origin, claiming they were refugees from the fall of Troy. Archaeological evidence shows striking connections between Elymian sites and the Aegean world. Sicilian artifacts have been found at Troy itself. The Elymians may have been Aegean or Anatolian maritime peoples who established trading posts on Sicily's northern coast. This three-way division created a genetic gradient that still exists today. Eastern Sicily differs significantly from Western Sicily, and this difference traces back to the Iron Age separation between Sicily, Sicanian, and Elymian territories. Then came the Greeks, and their impact was massive. Starting in the 8th century BCE, Greek colonists from Corinth, Euboea, and other city-states founded Syracuse, Acragas, Gela, and dozens of other settlements. Sicily became the heart of Magna Graecia, Greater Greece. The genetic evidence for Greek colonization is overwhelming. Y chromosome analysis, which traces the male line, shows that approximately 37% of modern Sicilian men carry DNA from Greek colonists. The key marker is haplogroup EV13, which originated in the southern Balkans. The time to most recent common ancestor for these lineages is about 2,380 years before present, dating precisely to the classical Greek period. But here's the fascinating detail. The Greek migration was heavily male-biased. While Y chromosomes show massive Greek input, mitochondrial DNA, which passes through the female line, remains more closely aligned with pre-Greek populations. This indicates Greek men married local Sicanian and Sicel women. The colonists Hellenized Sicily through the paternal line, creating a population that was culturally Greek but genetically a fusion of Greek men and indigenous women. This pattern appears repeatedly in ancient colonization. Men travel, women stay, populations blend. The Greek contribution is strongest in eastern Sicily, where the major colonies were established. In these regions, genetic distance to modern Greeks from the Aegean Islands and Crete is remarkably small. Sicilians from Syracuse or Catania are genetically closer to islanders from Crete or Rhodes than they are to people from Milan. While Greeks dominated the east, Phoenicians and their Carthaginian successors controlled western Sicily. The Phoenicians were master sailors and traders from the Levantine coast, modern Lebanon. They established Motia, Panormus, and other trading posts. The Phoenician genetic contribution is smaller than the Greek, estimated at about 6% of the modern population. The primary marker is haplogroup J2 and specific Y, STR haplotypes identified as Phoenician colonization signals, but Phoenician sites show remarkable diversity. Ancient remains from Punic cemeteries reveal mixtures of Aegean, local Sicilian, and North African ancestries. This reflects the cosmopolitan nature of Phoenician trade networks. They weren't conquerors imposing genetic uniformity. They were merchants facilitating exchange, and that included genetic exchange. The interaction between Punic settlers and indigenous Elymians and Sicanians reinforced the eastern Mediterranean character of western Sicily, providing a counterweight to the Italic signals arriving from mainland Italy. After the fall of Rome and the Byzantine period, Sicily entered one of its most transformative eras, the Islamic Conquest. In 831 CE, Muslim armies, predominantly Berber tribes from Tunisia and Morocco, invaded Sicily. They established the Emirate of Sicily, which lasted until the Norman Conquest in 1091 CE. The Islamic period added a distinct North African and Levantine genetic layer estimated at approximately 6% of the modern Sicilian gene pool. The key markers are haplogroup EM81, characteristic of Northwest African Berbers, found at frequencies of 2 to 5% in modern Sicily, and haplogroup J1, associated with Arab populations. This contribution peaks in western provinces like Trapani and Agrigento, where Muslim settlement was densest. Even after the Norman Conquest, Muslims remained a majority on the island until the late 12th century. Many were eventually forcibly relocated to Lucera in Apulia, spreading the North African genetic signature throughout southern Italy. The Islamic period also left profound cultural marks, visible in Sicilian language, architecture, cuisine, and agricultural practices. Couscous, citrus cultivation, and advanced irrigation systems all entered Sicily during the Emirate. But genetically, the Islamic contribution remains a minority layer atop the deeper Neolithic, Bronze Age, and Greek strata. The Norman conquest of 1061 CE introduced yet another genetic component. The Normans were descendants of Vikings who had settled in northern France. They brought a Northwest European genetic signature, particularly haplogroup I, found at frequencies of 15 to 20% in central and western Sicily, but only 8% in the east. This distribution seems counterintuitive since the Normans came in small numbers, but they encouraged settlement by Lombards, people from northern Italy and France, to re-Christianize the island after Islamic rule. Studies of medieval cemeteries show genetic discontinuity between earlier Muslim communities and later Christian Swabian period settlements, even when these groups lived in close proximity. The northern signal in Sicily thus represents a combination of Norman, Swabian, and mainland Italian migrations following the collapse of Islamic rule. The genetic structure of modern Sicily is characterized by extraordinary diversity. Gene diversity is estimated at approximately 0.904, reflecting the high number of different haplogroups coexisting on the island. But this diversity isn't uniform. A significant genetic difference exists between Western Sicily and Eastern Sicily. Eastern Sicily shows higher frequencies of Greek and Balkan signals. Western Sicily shows more Western European R1b lineages and North African markers. This east-west divide is primarily longitudinal rather than latitudinal, suggesting geography facilitated internal cultural and genetic separation. The western half remains more influenced by Norman, North African, and later Italian migrations. The eastern half remains more tied to the ancient Greek and Levantine world. This pattern traces directly back to the Iron Age division between Sicily, Sicanian, and Elymian territories, amplified by subsequent Greek and Punic colonizations. To understand just how different Sicilians are from Northern Italians, consider the key ancestry components. Northern Italians carry substantial steppe-related ancestry from Bronze Age Indo-European migrations. This gives them genetic affinities with Central Europeans. Sicilians carry minimal steppe ancestry. Instead, they preserve the ancient Mediterranean profile. Approximately 60 to 65% Anatolian Neolithic, the farmers who arrived 8,000 years ago. 20 to 25% West Asian or Caucasus hunter-gatherer, the Bronze Age mystery migration. 5 to 10% Levantine from pre-Phoenician and later contacts. Less than 10% steppe, arriving late through Italic migrations. This makes Sicily a genetic time capsule of the ancient Mediterranean world. While northern Italy was transformed by waves of Central European ancestry, Sicily remained oriented toward the sea, toward the east, preserving genetic components that have been largely overwritten elsewhere in Europe. The 3,000-year secret isn't a single event. It's the revelation that Sicily's unique genetic character was established in stages. The Neolithic Anatolian foundation, the mysterious Bronze Age influx of Caucasus and Near Eastern ancestry that no one expected, the Greek colonization that added massive paternal lineage diversity, the Phoenician and Islamic periods that reinforced the Eastern and Southern Mediterranean connections, and finally, the Norman period that added the only significant Northern European component. Each layer left permanent marks on the Sicilian genome. The genetic distance between a Sicilian and a Northern Italian is the result of Northern Italy receiving far more steppe-related and Central European gene flow over the last 3,000 years. Sicily remained a Mediterranean island genetically, even as it became politically Italian. Consequently, the Sicilian genome represents a biological archive of the ancient Mediterranean world, a world that connected Europe, Asia, and Africa through maritime networks long before national boundaries existed. The genomic data supports a nuanced answer to the question, are Sicilians Italian? Politically and culturally, yes. Sicily is part of Italy, and Sicilians are Italian citizens who speak Italian and participate in Italian society. But biologically, Sicilians are heirs to a distinct Mediterranean heritage. They are the descendants of Anatolian farmers, Bronze Age seafarers, Greek colonists, Phoenician traders, and North African settlers. They preserve genetic continuity with the ancient East Mediterranean world that has been diluted or overwritten in most of Europe. From the first Paleolithic hunter-gatherers to the Neolithic replacement, from the Bronze Age mystery migration to Greek colonization, from Islamic rule to Norman conquest, every wave of migration left its mark. This makes Sicily one of the most genetically diverse regions in the world. The island serves as a living biological testament to 3,000 years of Mediterranean history. It's not that Sicilians aren't Italian, it's that they're also something older, something that existed before Italy, before nation-states, before the modern categories we use to divide humanity. They're a reminder that the Mediterranean was once a unified biological and cultural sphere, and that genetic borders rarely match political ones. If you found this story of genetic discovery and ancient Mediterranean connections fascinating, consider liking this video and sharing it with anyone curious about the deep history hidden in human DNA. Have you discovered surprising ancestry in your own genetic tests? Share your findings in the comments so others can learn from your experience. We all carry ancient histories in our chromosomes, fragments of migrations and meetings that shaped the modern world. The question is whether we're willing to look closely enough to see them. I'll see you in the next video.